We now determine the intervals where the function is concave up, concave down, and also determine the points of inflection. So to determine the concavity intervals, we have to find the second derivative of the function and determine when it is 0 or when it is undefined. So let's find the second derivative. First, we differentiate this, that is, we find the first derivative of the function f of x, which is f prime of x. And to differentiate the right side expression, we should use the quotient rule. So I put the denominator term first, that is x plus 7, times the derivative of the numerator expression, that is the derivative of 5x minus 4, which is 5. And then I put minus. Now I put the numerator expression, that is 5x minus 4, times the derivative of denominator expression, that is the derivative of denominator expression x plus 7, and this equals 1. So I multiply this by 1, and this should be all over the denominator quantity square, so it is x plus 7 quantity square. Let's simplify this. So we have f prime of x, and this equals, distribute the 5 now, so it becomes 5x plus 5 times 7 is 35. Then we should distribute this negative, so it is negative 5x. Negative times negative 4 is positive 4, and this is over x plus 7 quantity square. And so this simplifies to this 5x, and negative 5x is 0, and then 35 plus 4 is 39. So it is basically f prime of x, and this equals 39 over x plus 7 quantity square. Once again, we should find its derivative so that we get the second derivative function. So before I do that, I rewrite this in the exponent form. That is 39 times of x plus 7 raised to the power of negative 2. Now we will differentiate this with respect to x. So I write f double prime of x, and this equals, we utilize this expression to find the derivative. So I put the constant as it is. Then I have to apply the power rule first, which is I put a negative 2 in front, and then x plus 7 raised to the power of negative 2, negative 1. We also apply the chain rule to differentiate the inner part. The derivative of x plus 7 is just 1. So I put 1 here. Now let's get this simplified. So we have f double prime of x, and this equals 39 times negative 2 is negative 78, and then this becomes x plus 7 raised to the power of negative 3, or else we can write this as negative 78, and this is over x plus 7 raised to the power of 3. Now to determine the concavity intervals, we should set up the second derivative equals 0, or it is undefined. So let's see at which points the second derivative is 0. Clearly, if we consider the second derivative expression, for all values of x, this is not going to be 0. That is, there are no values of x such that the second derivative equals 0. So we can ignore this condition and then move on to this undefined. We can clearly see that for x equal to negative 7, the second derivative is undefined, because when you plug in x equal to negative 7, we get denominator equals 0, and a number divided by 0 equals undefined. So clearly at x equal to negative 7, the function or the second derivative is undefined, and this means we can prepare a sign chart for the second derivative at x equal to negative 7. So let's do that. This is x equal to negative 7, and we need to put some random points to the left of negative 7 as well as to the right of negative 7. This is basically for second derivative. Let me put the second derivative expression, which is negative 78 over x plus 7 quantity cube. So first, I'm going to put a random point to the left of x equal to negative 7. I put x equals negative 8. So therefore, f double prime of 8, negative 8, and this equals negative 78 divided by negative 8 plus 7 quantity cube, and this equals negative 78 divided by, this is negative 1, and negative 1 quantity cube is negative 1, and this gives a positive number. So to the left of x equal to negative 7, it is positive. The second derivative is positive. And now let's put some random point to the right of x equal to negative 7. So I put x equal to 0, and so therefore we get negative 78 divided by 0 plus 7 quantity cube. And this basically is going to be negative 78 divided by 7 cube, and this is a negative number. Basically, we need only the sign and not the exact value. So clearly to the right of x equal to negative 7, the second derivative is negative. And this implies whenever the second derivative is positive, it is concave upward. So the graph will look like this. And whenever it is negative, the graph is concave downwards. So it looks like this. So here in this interval, we say that it is concave up, and here we say that it is concave down. So now we write down the intervals of concave up and concave down. So concave f is concave up in the interval from negative infinity to negative 7, and f is concave down in the interval from negative 7 to positive infinity. And so this answers question 1 and question 2. Now, to determine the points of inflection, we basically consider the function f of x, and this equals 5x minus 4 divided by x plus 7. So when we consider the point x equal to negative 7, where the second derivative is undefined, uh, we cannot consider this as a points of inflection, because if we plug in x equal to negative 7 into the function f of x is undefined at x equal to negative 7. Therefore, we see that there is no points of inflection. Or we say that the points of inflection is none.